Hey everyone, my name's Ishaan Hiranandani and today I'm going to be your IA. Today we're learning about cardinality of sets and specifically how we can use one-to-one functions to prove those. Without further ado, let's get to the question. Prove that the set of 0 to 1 inclusive and the set of 0 to 2 exclusive have the same cardinality. Essentially, we want to show that the cardinality of the set 0 to 1 inclusive, or which I'll just be calling set A from now on, is equal to the cardinality of the set 0 to 2 exclusive, which I'll be calling set B. So we can use this using the Schroeder-Bernstein's theorem, which just says that if we show that if the cardinality of set A is less than or equal to the cardinality of set B, and also vice versa, that the cardinality of set B is less than or equal to the cardinality of set A, then the cardinalities will be equivalent. So in order to show these functions, we can use functions, specifically one-to-one functions. So I'm going to draw two sets, and we're going to be taking a side step over here. Set A and set B. So let's call those set X and Y to avoid confusion. And we want a one-to-one function, f of x, that maps from x to y. Now, what does it mean for a function to be one-to-one? It means that every element in y is mapped to by only one element in x. And each element in x maps to only one element in y. And that's the definition of being a function. So, say we have two functions, and we draw a simple one-to-one mapping. As you can see, the cardinalities of x and y are equal. However, this isn't always the case. It could be true that there are some elements in y that don't have any mapping to them whatsoever. For example, if we had a third element in set y. As we can see from here, the cardinality of x must be less than or equal to the cardinality of y. And that's remarkably similar to what we want to prove here. Essentially, we're taking a one-to-one function that goes from set x to set y, or in our case, from set A to set B, and also another one-to-one function that goes from set B to set A. And if they're one-to-one, then we can show that the cardinalities are less than or equal to the other. And using those, we show that their cardinalities are equivalent. So, let's work on finding some functions. Let's start with from A to B. So if we want to go from 0 to 1 to 0 to 2, we need to find a function g of x. So my first thought is, why don't we just add 1 to to x? Note that so we can use some test cases to ensure that this is accurate. So this would map to 1 to 2. If we plug in 0, our lower test bound, into g of x, we get g of 0 equals 0 plus 1 equals 1. And that is in set B. What about our upper bound? If we plug in 1, g of 1 equals 1 plus 2, note that set B is exclusive. Unfortunately, this doesn't work. So what we need to do is find a way to compress our initial function and then add 1. So that's fairly easy to do. We could write g of x equals half of x plus 1. So if we were to map our revised function, how would that look? We're doing half and then plus 1. Again, let's plug in our lower and upper bounds. G of 0 equals half of 0 plus 1, or 1, which is still in set B. And G of 1 is equal to half of times 1 plus 1, or 1.5. And that's also in set B. So we found a function g of x that maps from set A to set B, and it's 1 to 1, showing that this is true. Now let's do the same thing the other way around. So if we have a function h of x equals, we want to map from 0 to 2 to 0 to 1. So my first thought is, let's just plug in the value. But note that if for our upper bound, it doesn't quite work out. H of 2 equals 2, which isn't in set A. However, if we were to again compress this, h of x equals half of x, then we would get the mapped function from here to here. Let's see how this works by plugging in our test cases. Note that our lower bound isn't 0, since this is exclusive. It's actually 0.000, infinitely many zeros with 1 at the end. I'll just say 0.0001. So h of 0.0001 is equal to half of that, or 8.00005. And that's in between 0 and 1, or set A. What about our upper bound? Our upper bound, again, is not 2, but 1.9999. I'll just leave it there. And h of 1.9999 is going to be equal to 0.99995. Again, that's within the constraints of set 1. So since we found two one-to-one functions that map from set A to set B and set B to set A, we can say that their cardinalities are less than or equal to one another, and hence equivalent. I hope you guys enjoyed learning with me today about cardinality of sets and one-to-one functions. Thank you!